Hello? Perfect. All right, so hello, my name is Silvana Moncayo. I work for the Input and Composition Engine team in Windows. I have been with Microsoft for 5 years now, with most of the time spent working on Direct Composition. So before we get started, I wanted to give you a quick background into how Direct Composition originated. So back in Windows 8, as part of planning, we came up with one of our biggest user experience principles, and it is called Fast and Fluid. You have probably heard about this on the Microsoft ads, the Windows Store, but what I wanted to tell you is what that statement meant to us, to the Windows team. For us, that statement was an opportunity to more closely join those fast, hardware-accelerated, advanced developer experiences with the fluid, smooth, out-of-the-ordinary end-user experiences. We saw an opportunity to just bridge that gap between what developers and designers think of when they're trying to create a great application. So there we took the exciting route of improving and adding key features to our system compositor, what you know as the desktop window manager. And as well as we started designing and exposing an API called DirectComposition that will give developers like you access to our very own system compositor. So today, I'm so excited to talk to you about how you can leverage those smooth transitions and animations you see on the start screen, or the fluidity of our video playback experiences. And I will show you how to do this, regardless of your application being a new desktop application or an existing desktop application. So let's get started. Quick look through our agenda. We're going to talk about what is Direct Composition. Then we'll go into why you should use it for your application. And we'll jump right into how you could use it in your application by building an app right here on the stage. So by the end of this talk, you should have enough concepts, enough composition concepts and best practices in hand to get your application started when you get home. So let's talk about what's Direct Composition. But first, let's talk about composition in general. So composition as an engine is what gets those pixels, that content, the content that you render on the screen. So any content that you have, any shapes that you have rendered with any technology, they hit the glass because of the composition engine. But as an API, it provides a level of orchestration via different features and different properties to show such content on the screen. So now Direct Composition is the Windows composition engine. It is underpinning the start screen, the Windows desktop applications such as Internet Explorer, and the Windows Store applications, all of the frameworks supporting the Windows Store apps. It is part of the DirectX family, so it is a hardware-accelerated API that works with Direct2D, Direct3D, and DXGI in a highly performance fashion. So this is a slide that covers all of the different desktop APIs that we make available for you. On the left side, you can see all of the APIs that you can use in order to get input from devices such as mouse, touch, and pen. The right side covers all of the APIs you can use to render content and to output that content to the screen. Furthermore, we also have APIs by which you can output that content into different types of DPI, different displays with different DPIs. Now, for this particular talk, I'm going to focus just on the rendering and composition pieces. So if we look at that stack, you'll see that the Direct3D technology is right at the bottom. It is the basis of our graphics technology. It is going to provide to-the-metal graphics performance. Then Direct2D and DirectWrite were built on top of Direct3D, and they offer 2D immediate mode rendering for bitmaps, for geometries, for text. Now, once you have the render bitmap, so once you have the red circle, the blue square, the JPEG bitmap, that video surface, you need to get it in the screen somehow, and that's where Direct Composition comes in. So Direct Composition allows you to show that content on the screen, but you can show it not just, pop it on the screen. You can actually show it with a transformation, an animation, an opacity effect. That's what Direct Composition will allow you to do with those bitmaps that you have rendered. So now, when I talk about what is Direct Composition, I always find it easiest to just show you where Windows uses Direct Composition so you can get a feel what it is for us. So let's take a quick look at the different places where Windows takes advantage of Direct Composition. So when you look at the start screen, the smoothness of panning, the smoothness of zooming are both powered by Direct Compositions independent of the, and of course you want to see the demo, there you go, independent of the UI thread composition engine. So if you look at the different applications installed on your start screen, you'll also see that there's smooth tickle animation that is bringing in those applications updates. That's also powered by Direct Composition. If I launch the Charms bar, you can see that all of those charms come in with a nice opacity and translate animation. They don't just pop, they actually come in with an entrance animation. And then if you look at our own Windows logo, that's using the 3D perspective transformations that DirectComposition enables applications to consume. Now, this is something that you can do in your own application if you're trying to add something different to a particular item within a menu, for example. So let's look at a few applications. Let's look at Internet Explorer. And here you can see that the smoothness of panning, the smoothness of zooming translates within an application. It's not just for our system components. Another thing that you can see is the Internet Explorer team did something very cool here. So they took an existing scenario, which is the back button, and they created something more engaging to the user, something that will be a little bit more just nice to see. So if I now navigate to a new page, you can see that I can go backwards to the previously navigated page, or I can go forward to the current page with a nice opacity transition. Another thing that you can do is if you go and you search within a particular IE page, you see that the software keyboard will come up. And this is a system component being composed on top of an application. Those are the sort of things that DirectComposition can do for you. So let's take a look now at, because we have DirectComposition, like I mentioned, is a system compositor, we also support those store applications. So let's take a look at Windows Web Application. Now, this is a good example of an app that has a lot of data to show to the user. And of course, you don't want to make your application overwhelming. And so here, they use DirectComposition in order to hide and show the different pieces of content. So you can see that here, if I want to look at the weather for the whole week, I can just add a nice animation. Same thing if I want to look at the different details for the weather for each day. Now, if I pan to the right, there's a historical weather data chart. And if I touch at each one of the months, you see that the data for each month comes in with a nice opacity animation. So it's just a nice way to show the users the different types of weather for the different months without creating a huge table and without adding a ton of information that is just hard for your user to consume. Now, we looked at Windows Web Applications, we looked at Internet Explorer, so let's take a look at a XAML-based application. So now, this is a good example of an application that really cared about those details. Like, they really focused on polishing the app. So for example, if I select a color for each one of the, for the brush color, you see that there's just a nice transition going in there, and that just makes me feel as a user that, this application is real. I'm actually painting here. So if you switch between the Surface menu and the Tools menu, again, there's a nice transition going between the two. And then a simple transformation for when you select each one of the papers just lets your user know that you're reacting back to what they want to do. You can do fun things such as bringing down the background color palette with an animation. And then one thing that I want you to notice here, and you may not know because that doesn't come with the app, is this surface, where you can go and draw, is a DirectX surface. And the menus that you see on top are like XAML controls. So DirectComposition allows you to just take a DirectX technology with the XAML controls, put them both together, and they work in one single application. So DirectComposition doesn't only work for store apps, of course. It works for desktop applications as well. So let's go and take a look at Internet Explorer on the desktop side. So here I'm going to jump a little bit ahead and just start teaching you about a couple of concepts for DirectComposition. So I'm going to launch a page that the Internet Explorer team put together in order to show CSS animations on top of SVG-based content. And what they provided was that I just have a private debug extension by which I can highlight all of the different DirectComposition objects that are now on the screen. And something to notice here is that not only are we using DirectComposition to support those CSS animations, but we rendered all of these bitmaps beforehand. So for example, the eye of the fish is just a circle that we rendered way at the beginning. And then we're using transformations, we're using rotations to change that content and to make it live to the user. But you don't have to keep on re-rasterizing your content in every single frame. All right. So I talked about what DirectComposition is and the many places we use it in Windows. So if you have used Windows, you already like DirectComposition. But still, why should you use it for your application? So the first thing I wanted to tell you is we're here to support your scenarios the same way we have supported the Windows scenarios. We talked about smooth animation, smooth panning, smooth zooming, and those are all possible because we run independently of the UI thread. So it doesn't matter if your application is doing a lot of relayout calculations or you're just doing a lot of work on the UI thread, your animations, your panning, your zooming are going to still be smooth. And that's important because those are the sort of, intentions that whenever a user is trying to pan, well, they want an instant reaction. They don't want to wait until the UI thread is done with your calculations. Now, for video, direct composition is always running at high priority, and it allows a media engine to provide those video frames directly to the system compositor. And that's better than providing those frames to any framework, because that means that you will require more composition delays. Interoperability. So I'm sure that many of you have spent a considerable amount of time creating your own UI controls, your own pieces of UI. And if I were to tell you that direct composition is amazing and you should use it for your app, but the next thing I asked you was to rewrite your entire application, I am pretty sure you'll just tell me, well, that's unacceptable. And you will be right. So now, this is not news to anyone. Different compositors have done different things to solve this problem of bringing content that already exists into a composition scene, but they all end up running into one single problem, like similar problem, and it's called the airspace problem. So how many of you know what I'm talking about when I describe the airspace problem? Well, actually, quite a few hands. Now, WPF runs into this problem, and the issue is really about when you're trying to compose child windows, you can compose them, but they're always going to end up on top of everything. And then the content behind it is going to be clipped. So now the WPF content behind is clipped. Then if you try to add a transformation or an animation to go with that scene, well, you're going to end up running into visual artifacts. The good news is that direct composition will solve that problem for you. So we have an ability to let you take your content, your existing content, and make it part of the direct composition scene. And then you can just treat that same, those different pieces of content, like Direct2D with an MFC-based control, and you can just animate them both together as one single piece of content within your application. Now, we also offer 2D transformations, 3D transformations, clips, effects. And the nice thing about that is that any composition updates that you make, so if you add a transformation, an effect, a rotation, we can take all of those changes and we'll make sure that we can atomically show them on the screen. So we'll take all of those changes and we have a method by which we can say this needs to land in one single VBlank. So in order to show you why you should use it for your app, we actually put together a technology demo to just show you the different features and the different things that direct composition could do for your application. So here I have a simple viewing application. And if I bring in content for the app, you see that when I bring in the content, that actually comes in with a nice entrance animation, very similar to what the Charms bar has. Now, when I go and select different images to send them to my viewing pane, you see that the frame that I created is actually changing according to the picture size. Another thing that you can notice is that as I'm changing through the different pictures, the old one is fading out and the new one is fading in. So this is a very, very simple concept, but because I'm adding those transitions, those animations, it just makes it look a little bit more interesting. Now, direct composition doesn't just compose static content. It actually composes live content. So here I have a video surface. When I animate it to the viewing pane, you can see that the video just keeps on playing. So let's take another video. If we animate it, you see that the video just keeps on playing. If we add an animation now, you can see that as the rotation is going, there's no frames dropping, there's no glitches on the video. This is just a smooth animation going on live content. I have more than one video on this application as well. So if I do the same thing with the other video, you see that Stewie just keeps on typing. Now, I have more content here, but are you ready for this? All right. The next piece of content is actually going to be, and we need to connect, of course. I have an ActiveX control hosting our own web browser. And the way that I created this ActiveX control is with MFC control. This is actually MFC below Direct2D content. So these tips are Direct2D content. I added some transparency to them just to show you that we are actually composing. We're not clipping. And here's the MFC control. It's perfectly functional. So if I go and I try to pan, or if I zoom, you can actually see that that shows up on the thumbnail view on the left side. Now the real test is, can I go ahead and animate this, guys? And look, it animates. You're just seeing the airspace problem being solved right in front of you. So now, all right. Thank you. All right, so let's go back to our slides now. So what did we just look at? We looked at a direct 2D bitmap. We looked at a DXGI video. Then we have more D2D content in order to draw those frames, those tapes. And then you have an H1-based control. So when you look at this application, you have a mix of technology, just a mix of rendering technologies. But what's important to the end user is that this is just a viewing application. You shouldn't have to care about what type of content you're rendering. It's a viewing app. Now, for the application that we're going to build, I'm actually going to take a piece of this application, and we're going to teach you the basic concepts of direct composition by creating those tape surfaces. And then at the end, I will go ahead and add the H1-based control such that you can see the interoperability value out of direct composition. So let's look at the app that we're going to build. All right, so here, as I mentioned, I'm going to take those tape surfaces. We'll teach you how to create your visuals, how to add this content. Then we'll animate those tape visuals around. Then at the end, we'll add this H1-based control such that you can animate the two pieces as one single piece of content. Okay, so to create the application, I just divided the app into these 8 different steps. And as we go through all of the different steps, I'll give you some quick introductions, some definitions for direct composition. Then we'll go into Visual Studio, we'll type some code, we'll run the application, so you know what to expect when you go and you build the application at home. So let's talk about the first 3. So here's where we're going to create our device. We'll create the H1 composition target, and we'll set up our composition visual tree. So let's talk about the device and the H1 composition target. The main direct composition object is the device. It is a very lightweight object, and it has 2 main functions. One, it is a factory of all of the other objects, all of the other direct composition objects, and then it takes control of that coordination, that transactional behavior that we talked about. So the device holds on to a method called commit, which is very similar to, if you have used DXGI, there's a call in there that's called present. The commit is very similar to that. Anytime that you call commit on direct composition, we know that you want to show content on the screen. So we know that we are ready to just go and show all of those composition updates you've been making on the screen. Now, direct composition composes bitmaps. It composes render content. But if you want to render your content as you're adding your animations and your transitions, you can associate the direct composition device with a DXGI device or a D2D device, and that's how you can update your content. The direct composition content can be bound to a top-level window or a child window. So as long as you have an H1, you can bind content to it. And then in order for me to explain how to think about a composed window, I thought the easiest would be with a little diagram. So here you have the composed window. And this is just a mental metaphor to start thinking about the different layers that you will have in a composed window. So you have your parent window, which you're already familiar with. Then you have a direct composition layer, so that's bottom direct composition layer. Again, this is not a bitmap, it's just a mental metaphor. That's where you're going to add the different pieces of direct composition content that you want. Then you have your child windows, and then you have another direct composition layer. So we can have content below the child windows or above the child windows. So if we take the application that we're building, you see that we have the parent window, then we're going to have the browser as the child window, and then we'll have that top direct composition layer where we're going to add those tapes. So now let's take just that direct composition layer, and let's talk about visuals and visual trees. So that's what we use to describe those entities that you're going to add to the composition scene. So your direct composition visual tree starts with a root visual, and the root visual is what's going to be attached to that composition target. After that, you can build this structure any way you want. I mean, this is just one of the options, and it depends on the way that you want to think about the different visuals that you want to expose on that application. So in my case, I just created one that I'm calling it a container visual. The reason why I'm calling it a container is because I don't need to bind any content to it. I'm just going to add a transformation to that one, and then I'm going to animate the transform. So that's the one that is holding on to the entire transform to move the tapes. And then the tape visuals on the bottom are the ones that are actually going to be bound to the green surface that you see, like those green tapes that you see on the top. So let's go to Visual Studio, and we'll take care of those 3 steps. So we'll create the device, we'll create the composition target, and we'll set up the visual tree. All right. So now before we start, let me just run the application so that way you know from where we're starting. So this, as I mentioned, is an MFC application, and it just has the top-level window in that browser. It's just an ActiveX control within the MFC app. So now I'm using snippets, a very cool feature from Visual Studio to just be able to type faster here. So let's just go the first 3 steps. So here we're going to initialize direct composition, set up the visual tree, and then remember, every time that we make a change, we're going to call commit. If you don't call commit, you won't see the changes on the screen. So let's go to the initialization function, and here we're going to create our device in the composition target. When you create the direct composition device, the first parameter is just the rendering device. So you can pass null in here if you like, but in my case, I want to render those tapes with Direct2D, and that's why I'm passing a Direct2D device. Then you're going to ask for the type of device you wish to create, so we want a desktop device, and then you'll get back the newly created device. Then we're going to create the target for composition, and here you're going to pass that H-wind, the H-wind that you have from the MFC application. The second parameter is the one that allows you to specify if your direct composition layer is going to be on top of the child windows, that means true, and if you want it to be below the child windows, it will be false. And you can have 2 of them. And then we return the newly created composition target. So now let's create the root visual. So we're creating the visual, and we're just calling it root visual to match the diagram that I just showed you. And then we're going to set the root visual on the composition target that we just created up here. So now we have direct composition initialized, so let's go and set up our visual tree. So let's create the container visual. So here we're creating the container visual, and we're going to set it as a child of the root visual. So here's where we start setting up that composition visual tree. So we have our first child. Now let's create those tape visuals. And here, same thing. I'm creating the top left tape visual, and I'm adding it as a child of the container. And it will be the exact same exercise for the other 3 visuals. So you create the top right, you add it as a child, you create the bottom right, it's a child of the container visual, same with the bottom left. So let's run the application. Now here you may think that you're going to see content, but remember that visuals and visual trees are all about structure. So right now we have the structure set up, but we don't have any content bound to it. So let's take a look at how we can do that. All right, so let's set up some content, and then let's bind that content in a structure such that you can start seeing those tapes on the screen. So when we talk about the different types of content, direct composition has this whole list to offer. So the first 2 are direct composition surfaces. These are new and just specific to direct composition. And the difference between those 2 is that the first one is a logical surface. So it means that all the pixels are realized in video memory already. So this is good for a small image or like a control. So if you want to realize that video memory beforehand because you're not using that much memory, then that's the surface to use. We also have virtual surfaces, which are very useful if you want to realize the video memory, but you want to realize it as you need it. So this is useful for things like a maps application, where you don't want to render the whole map beforehand, but as you have, like the user is looking at a particular portion of the map on the screen, you'll realize that portion. Then as the user is panning or zooming, you can discard the old pixels and you can realize some new ones. And direct composition has methods by which you can discard those pixels, create new ones, and you can manage that virtual surface. Then we have the DXGI swap chain, and this is the same swap chain that you're used to already. So it offers deep queuing of buffers and presentation intervals. It is used for videos and games. Same swap chain you have used before. Now, layer child windows is a new concept to Windows 8. So before Windows 8, you were able to layer top-level windows. Now you can actually layer your child windows as well. And what it means is that anytime that you layer a window, we create another redirection surface. And that's the redirection surface that we're going to use for composition. So this is the surface that you're going to use if you're trying to get H1-based content, so some content that you already created and you want to make it part of the direct composition scene. So once you create that content, you may want to update the content over time. So if you have a scale transformation and you're trying to go from one bitmap to another, you probably want to update that surface. And so direct composition allows you to do this on logical and virtual surfaces via two methods. One's called begin draw and the other one is called end draw. And they're pretty prescriptive. I mean, the begin draw just tells you that you want to initiate an update. And when you call end draw, we know that you're done with the update. The reason why this is important is because that's the way that you tell us that we are free to show that content on the screen. We know that if you haven't called end draw, you're in the middle of rendering, so we won't show those updates on the screen. Once you call in begin draw to initiate an update, you're going to retrieve a DXGI surface or a Direct2D device context. It depends on what update object you ask for. And then you're also going to get an offset, and that's the offset that you need to use in order to render your update. Now, once you call end draw, that means that the update is done. And remember that after every single one of those composition updates, you have to call commit. That's the only way that we will know that, okay, we're free to go and show the content on the screen. So you can picture having two surfaces. One you call begin draw on, and the other one you call begin draw and end draw, and then you call commit. We'll show the updates for the begin draw and end draw surface. We won't show the updates for the one that you just call begin draw on. The content updates for a DXGI swap chain and a layer child window are a little bit different because they are asynchronous. Since these are surfaces that already existed before, those content changes just trigger a screen recomposition regardless of the structural changes that we have on direct composition. So we respect the fact that if you have a DXGI swap chain and you call present, that means you need to make an update, and so direct composition just stays out of the content updates. And for the layer child window, anytime that you call any Win32 API to make an update to the actual window, we'll just show it on the layer child window as well. Commit takes care of those composition updates such as the transforms, the animations, but then it does not take care of any of the content updates. So let's go to Visual Studio and we'll create the direct composition surface for the tapes, and then we'll associate it with those four tape visuals. All right, so let's go back to our list. We already initialized direct composition. We set up the visual tree. And here, let's just go and set up our content as well. All right, so we're going to create our visual content. So let's go to the function. And here you can see that I'm creating a WIC bitmap source, and that's just not specific to direct composition. So I won't go into that in detail for this talk, but here is where we're going to create our surface, our direct composition surface. The parameters that you're going to use for that method are you're going to pass a width for the surface that you wish to create, a height, a pixel format, an alpha mode, and then you'll get back that newly created direct composition surface. So here I'm creating just a regular surface because those tapes are so small that I can just render them beforehand. Now we need to begin draw on that surface. So let's call our begin draw. The first parameter is going to be your update rect. And if you pass null, it just means that you want to update the entire surface. Then you're going to ask for your update object. In our case, it's a Direct2D device context. And we'll return back the D2D device context and the offset. So notice here that when I go and I draw the WIC bitmap, I'm using the offset and the device context that I got back from the begin draw call. Since we're done with the update, we can call end draw. And now, just like any of the methods that you have on direct composition, you have any of the objects that you have with direct composition, you have a way to create the objects, and then you have a way to set them on a visual. So here we're going to set the content. So now you see that I am setting the content being the tape surface on all of those visuals. One thing to notice here is that I have just created one piece of surface, like one surface in video memory, and I'm using that exact same surface to attach it to all of those four visuals. So this is pretty cool because you can just use one piece of video memory and then show it in 4 different places without having to pay for extra memory. So now let's go and run this app. And here you go. You see the tapes, but of course they're one on top of the other, and they're at the 0, 0 coordinates because we have not added any visual properties such that we can position them correctly. So let's look at that next. Here we go. All right, so we're at the point that we can create and set those visual properties. For the visual properties, we offer this whole list. And so the offset is just the property that you use to position your visual correctly. The clips, we have a rectangular clip and a rounded corner clip. We have 2D affine transforms, 3D perspective transformations, a constant level of opacity, so a constant level of transparency for your visual. Then we have interpolation and edge mode, and that's just an anti-aliasing mode for your content and the borders of your content. Composite mode, we have 2 more options besides the typical source over. So we have min blend and destination invert. And then we have backface visibility. So this is the property that you will use if you're rotating your visual in 3D in perspective with a perspective transformation and you want to see the backside of it. All right, so let's go and position those tape visuals correctly. All right, going back to our list. We already took care of initializing, setting up the visual tree, and let's go ahead and set up the animations, or rather the visual properties. We're not at the animations yet. All right, so here we're going to set up the visual properties. So we're going to create a 45 degrees rotate transform for the bottom right and the top left tape visuals. So let's create the transformation. So all of the objects, I don't know if you've been noticing so far, but all of the objects are created on the device. So as you can see, all of the visuals and the transformations that I'm creating, they're all on the device. So now I'm creating the rotate transform. Then one of the parameters that it will take is an angle of rotation. So we want it to rotate 45 degrees. And then that property takes a center of rotation. So I'm here just specifying the center of rotation to be the middle point of that tape. Then we're going to create the negative 45 degrees rotation for the other 2 tapes. And the only difference with the first one is that now you're setting the angle of rotation to be the negative 45 degrees. The center of rotation is still the middle point of that tape. Now we need to set that transform on a particular visual. So let's set the transform 1. You see that I'm using the same rotate transform that we created for the 2 tapes, the top right tape and the bottom left tape. Let's do the same thing with the other 2. All right, now you can see the rotate transform 2 is being set on the top left and the bottom right tapes. So now you saw that we had a little bit of transparency going with those tapes. So here's where we're going to add the transparency. So we will create an effect. That's the name of the property. So we're creating an effect group, and we're setting that effect group to have an opacity value. You can change that opacity value to go any number between 0 and 1, obviously. Then we're going to set the opacity value on those visuals. And we're using the same opacity for all of the tapes. So here you just see that I'm using the exact same effect group. Here I have a function just updating the visual offsets. And because it's a lot of layout and just simple math, I just decided to skip that function. All right, so let's go and run that application. And now you see the tapes on the right locations. So now I'm sure that you are ready to just animate those. So let's go and talk about animations. All right, so we're at the last 2 steps. So let's create and set those animations. So let's talk about direct composition animations. Direct composition is a low-level, flexible animation execution system. The animation functions are just a list of segments, and those segments are primitives, and the primitives can be a cubic polynomial, repeat, and sinusoidal. The Windows Personality Library and all of the different Windows applications are actually creating the animations that you see based on these primitives. So they give you a really good variety. Now, once you have that animation function, you can set it on an animatable visual property. The animatable visual property just means that you have a 1D scalar that you can change over time. So for example, you can animate the angle of rotation in a rotate transform, or the center of rotation in the X direction for the rotate transform. Now, once you set the animations, you set the animation function, and if you want, you can leave it running forever. Once you want to end it, you just replace that animation function for a constant scalar value. And that's pretty intuitive. Like if you replace it for the scalar value and it's constant, then we know that we just don't need to animate it anymore. So let's go to Visual Studio. Let's animate those tapes. All right. So going back to our list again. And we're thinking. And not responding. All right, let's give it 20 seconds. Doesn't Visual Studio know that we're excited to go get our free devices at 6 p.m.? Like, dude. All right, I'm thinking we go for the backup. All right, let's go for the backup. We don't have time to wait. Different option. Let's let it think. Let's talk about interoperability, and then we'll come back and do animations and interrupt at the same time. All right. I just don't want you to see the entire application before I'm done with it. So, all right. So let's talk about interoperability. So the last thing you will have seen is those tapes animating around the browser. And of course, now we want to make that browser part of that animation. So in order to make it part of the animation, that means that you already have that content and you want to make it part of the direct composition scene. So the first thing you need to know is that the child windows are only composed when they're layered. So the one thing that you need to do is you need to add the Windows 8 compatibility to your manifest. And you need to do this just because the layered child windows is a new feature for Windows 8. So we need to know that you have tested your application with the layered child windows, and that's why you need to add this compatibility to your manifest. Then you're going to set the WXCX layered style bit on your window, and you're going to call set layer window attributes or update layer window. The difference between those two is that one takes a constant level of opacity while the other one takes a per pixel alpha. So once you have that window and it has been layered, direct composition has a method called create surface from HWind. And it's pretty simple. Like you just take that method, you are going to give it an HWind, and it will return back a direct composition surface. With that direct composition surface, you can assign it as content to the visual. Then you can add the visual properties, you can add the animations, the same way we have been doing the exercise for the tapes. The way that you can think about this surface is just like a thumbnail. It's just a second instance of that window by now on the screen. Now, in order to animate that HWind-based visual, you're going to play a little bit of smoke and mirrors. So what happens is you have the real window, the real layered window, and now you're going to have a second instance of it, which is the HWind-based direct composition visual. So we have a feature called cloaking that allows you to do this. The cloaking feature allows you to hide and show the actual window, but it won't stop it from actually, rendering. So although we hide it, you can still see that the HWind-based direct composition visual will show you all of the output updates. So once you can use this, the easy steps to take will be you use direct composition to animate that HWind-based visual. You're going to hide the real window as the animation is going. When the animation ends, you can bring back the real window. The reason why you're playing with those two is because the real window is what gives you the input, what will take the actual window messages, whether the HWind-based visual would just show you the output. But it would be completely coordinated with the actual window. All right, so let's go back, see how we're doing over here. Okay. Now it looks like it came back, so let's just see what state we have in here. All right, so the animations are not there yet. So I think we're good. Let's go to the animations. All right. So we're going to take care of the two pieces at once. We'll add the animations, and then we'll add the interrupt content to it. Okay, let's go to that function. So here I'm going to create a rotate transform that we're going to use in order to animate those taped visuals. So let's create the transform. So here I'm creating an animation rotate transform. And the center of rotation for that one is now the middle point for that container visual. Then we're going to set that transformation on the container visual. But now this is just the animation rotate transform, and we want to animate it, so let's create an animation object. So here we have a rotation animation, and we need a function to go with it. So here we're going to create a cubic polynomial. Out of those segments that I showed you, I'm using the cubic polynomial in this case. The first parameter that you see is just an offset in time. So this is the parameter that you will use if you want to delay your animation. So in my case, like anytime that I'm clicking that animate button, I want the animation to start right away. So that's why it's 0. But you could add a 2-second delay, 3-second delay, anything you like. Then this is the value that is changing over time. So we are going 360 degrees over the animation duration. And I just defined the animation duration beforehand to be 2 seconds. It can be anything you like. Now we're going to set the end value of that animation. And the end value is going to take an end value in time, which is the 2 seconds, and an end value with respect to whatever you're animating. So in this case, the 360 degrees. So let's go and try that out. And now you can see that the tapes will animate. So we talked about interrupt already, so let's go and add the interrupt content. So here, let's go and add our interrupt. Like I mentioned, the first thing that we need to do is layer that browser window. So here what I'm doing is I'm just getting the window style. And then in this call, I'm adding the WXEX layered style. Then in order to finish the layering of the window, we need to call set layer window attributes. And here I'm passing an alpha value, and I'm just adding 255 because we don't want that browser control to be transparent. You can actually make it transparent. In my case, I just keep it opaque. Now here's where we animate that browser visual. So we need to create a browser animation visual to start playing those smoke and mirrors that I mentioned. So here's my visual, the browser animation visual, and here's the method that we talked about, the create surface from HWind. So I'm passing the browser HWind, and I'm getting back the DirectComposition surface. With that surface, I can set it as the content for the browser animation visual, and then I can go and make it part of that DirectComposition visual tree that we created at the beginning, so I'm making it a child of that container visual. So now it's a sibling of all of the tape visuals. So we can now cloak that window, meaning we're going to hide the actual window because we have the browser animation visual. So I'm setting the flag to true. Here's where I'm going to cloak it. And here I have a timer. So I set up this timer let's actually take a look at that. So I set up the timer where I have my function that anytime that you click on animate, this function gets activated. So we already looked at the transformation is going to be activated, and then we're going to animate the browser. And here's where I'm setting up my timer. This is a simple timer that is just keeping track of when you click on the animate, it starts going, and it's going to go as long as the animation is lasting. So now when you look at when I'm going to uncloak the window is when that timer has expired. I am going to go and uncloak the window. All right, so let's run the app. And now you can see that the tapes and the HWind-based content are both animating at the same time. Direct 2D and HWind-based content, both going. Now, because I'm not seeing enough excitement, let's go and add something else. All right. So I'm actually going to go and add a 3D transform. Let's go and create a 3D transformation here. And of course, we don't want to create it if we can animate it, right? So let's go and animate that 3D transform as well. And now let's run the application. And when have you seen an H1-based control animating that way? Really? Like, when have you seen the airspace problem being solved and animating like that? All righty. And you'll get all of this code after the talk, so you can show it off to your coworkers. All righty. So with that, I really do think that you're ready to use direct composition. I mean, I told you about what direct composition is, the many places where Windows takes advantage of it. We have tested it for you. We know it works. We're very excited about it. Now it's your turn to add those engaging, those fast and fluid, those smooth scenarios to your application. And just don't forget that you can keep your code. You can move your existing code forward without having to rewrite your entire application. So some resources. If you missed some talks like at the beginning of the day, these are very good talks to go and check out online if you couldn't make it today. The first one talks about all of the different investments we're making for the desktop. The second one gives you an overview of all of the input technologies that we have, so all of the left side of the diagram. And then the third one is giving you an overview of the different types of displays that are coming in the market and how you can take advantage of that for your application. There's a link to the direct composition documentation, and there's plenty of samples to help you out as well. I hope you enjoyed the talk and enjoy the rest of the conference, and run to get your free devices. Thank you.